We have a handful of Intel processor bugs this week. We'll give you the details.
Hey, Matt, I hear you have a story about new secret spilling hole in Intel CPUs.
Yeah, so we've got a couple different Intel bugs this week. So two of them were reported by Sentinel-1. One was reported by Positive Technologies, and I'll just briefly go over each one of those. So Sentinel-1s are both CVSS scores of 8.2, both of which are local privesc bugs on a number of different Intel processors. So Xeon, Core, Celeron, and Pentium. It's a bit of a mix. So the full list is available on Intel's website. I recommend you check it out if you're interested in this sort of thing. But the first one is insufficient flow control in the BIOS firmware. The other one is improper input validation, both of which lead to privesc. I was a little confused about the write-up that I read. It said that these bugs require physical access, but also it's possible to take advantage of them if you already have an existing foothold on the system. So to me, that sounds like maybe yes, maybe no. I'm not quite sure where the lines are drawn, and there's not a lot of technical details as to how exactly the bugs are exploited. So these are bugs that allow you to escalate privs to the system management mode, or SMM, have to do with corrupting SMRAM. So lots of good details to dig into, hopefully at some point in the future. But for now, we have CVE numbers and a bunch of BIOS files from our OEMs to go and patch. The other one is from Positive Technologies. Now, this is a group that, if you've heard them in the news recently, they're on the U.S. sanction list for alleged ties to Russian intelligence. But they got a darn good bug. Can't really say anything bad about that. It's a 7.2, not nearly as high as the other one, but real interesting. It seems to be some sort of physical attack against Pentium, Celeron, and Atom CPUs of a bunch of different refreshes. And the quote from Intel is, hardware allows activation of test or debug logic at runtime for some Intel processors, which may allow an unauthenticated user to potentially enable escalation of privilege via physical access. Which is to say, you do something to it physical, and then you can recover keys that are used to do things like encrypt the data in the TPM, bypass code signing. Like this is some pretty important stuff. Apparently, it has to do with fuses. There's security fuses. The way that they store like some sort of primary key on these Intel devices, each one gets its own unique key from which other cryptographic things sort of get derived. And it has to do somehow with hardware fuses. At least that's what we understand. Again, this is one of those bugs that, very important, needs to get fixed, but not a lot of technical details are forthcoming yet. And there was something interesting in Ars Technica's write-up. They say the attack takes about 10 minutes. I'm not sure who they got that information from, but that to me sounds like it's not quite as simple as like walking up with some sort of connector that's standard. You probably have to crack open the device and somehow physically connect to some aspect of the processor in order to achieve this. But this one definitely requires physical access. So Intel also has a UEFI BIOS patch for this bug, so expect your OEM to provide that as well. And naturally, no evidence of exploitation in the wild for any of these, but I don't know exactly who's looking for that kind of exploitation in the first place. Most security platforms that I'm familiar with don't even start looking at UEFI.
So you're saying in the article that they mentioned that they can kind of potentially take the chip and modify, or take the processor, adversary can then modify it and then potentially like place it in a working virtual machine or server.
So yeah, it sounds like once you have physical access to one of the machines with the affected processor, you take it, you do some sort of physical magic to it for about 10 minutes, and then you are given the keys that are needed to do a whole bunch of other attacks. I don't really exactly know what is required here, being that there are physical security fuses involved. At least that's what we're gleaning from this. They may have some way of inspecting those maybe they have to take it to a lab for 10 minutes and put it under some sort of electron scanning microscope or X-ray it or somehow. But like the only thing I could think of is looking at the physical characteristics of physical fuses, because again, these are things that like I don't know how familiar you are with fuses on processors, but like you can burn out physical fuses and they can never be reverted back to their original state. And that was something that I was first introduced to back in, I think, with the Xbox 360 when they started doing that for their software updates to those systems. You could not revert back to an earlier firmware because they burned out fuses every time that they did an update. So it's kind of a neat technique, but it is something that physically changes within the processor. And I imagine the attack is some sort of inspection of those fuses to glean some sort of secret that most people wouldn't be able to get a hold of. Again, that is speculation. But given the little bits and pieces that we've been given through the articles, that's kind of where I think this is going.
Right. Yeah, I'm glad to hear that the patches are out, because to be considered part of the trusted computing base, it has to be correct, it has to be tamper-proof, and it has to have complete mediation. So obviously, if the hardware can be tampered with, it's not going to go well for any operating system or applications running on top of it.
Yeah, and I'm curious how a software patch to a hardware issue is going to work out in the long run for them. If they had to somehow change something about the security model of how things actually operate in order for that software patch to make any sense. But again, wish we had more to say about it.
Yeah, well, these hardware issues with the CPU and the subsequent firmware patches or whatever are always tricky and always make me really nervous, because that's all stuff that's going on pre the operating system actually booting up.
Yep.
And that's, if the bad guys can get in there, then it's game over. So when you see these updates coming through from your OEM, from your operating system, distribution, those are the kinds of patches that need to be applied immediately. You can't fuss around with those, because if the attackers manage to pick you out before you've applied the patches, you may never know that you were compromised.
Yeah, and any future attempts to actually patch might not actually take effect because the software's already been replaced, and it can just say, I'm going to pretend to accept updates.
Right.
No other way of telling. I wonder what the used server market's going to be like in a couple of years, where it's like, you can buy this but if you've got specific security reasons, maybe don't, because these CPUs haven't been patched, or we're fairly sure they weren't patched in time. Like, that's going to be a great question. How do you treat used hardware like that? Can you ever, or do you just have to say, I've got something that requires absolute high trust, and therefore I've just got to throw everything in the garbage and buy something brand new and hope that there wasn't a supply chain attack involved? Yeah, I don't know.
Scary world.
I guess to that point, if you throw out an old laptop, make sure you take your hard drive out.
Well, the hard drive, that's a whole other question. We're talking specifically about the processor
Right.
here. And that's something that like people I know will throw out hard drives separately from their computer, or maybe they'll hang onto the hard drive and get it thrown out somewhere special, or like wipe the disk platters or something like that. But I don't know of anybody who goes to the lengths of destroying or taking any special measures around the processor.